Hello, I'm here now. Just organizing some things. I don't turn the volume on until I'm ready to talk, so a lot of times it's going to be quiet. Today we're going to be looking at graphing proportional relationships. It's actually pretty easy to do. There's not much to this as long as you can make a graph and as long as you can read your graph and it's neat. You should be pretty easy about it. We will do similar figures some other time, Eli. It's coming. We're going to do graphing proportional relationships first. Today is technically a half day, so I'm not going to keep you on very long. Do a couple problems, and anything that is assigned today, it's going to be due by the end of the day tomorrow. So you'll have today to work on it, and you'll have tomorrow to work on it as well. But a lot of you probably can figure this out without a live stream. But let's do a couple problems and see how you do this. It is nothing really new. It's just kind of putting a different spin on proportions for you. So if you are following along with the PowerPoint, there are a few reminders that I want you to know. So first off, I want you to remember graphing. So this here, I can draw straight lines vertically at all. This here would be your coordinate plane. So you have your y-axis up here. You have your x-axis down here. You have your origin at point 0, 0. And you remember you plot x's first and then plot y's. Yeah, we can get through the Google Docs. We're doing whatever's graphing proportional relationships, so follow along with the PowerPoint that's provided, or the slideshow that's provided. It should be called graphing proportional relationship. Right. So I just wanted to remind you, hey, this is what a graph looks like. This is what we're going to be doing. But before we get there, we have to know what we're dealing with here. So you're going to get problems that are going to ask you to graph this proportional relationship. So you have a problem here that says 8-minute shower uses 16 gallons of water. If the shower time is reduced to 5 minutes, how much water will be saved? And use a graph to solve it. So basically it's giving you a ratio here. 8-minute shower uses 16 gallons of water. So you have your ratio of 8 minutes to 16 gallons. And hopefully that's pretty easy to pick out by now. You've been doing that for the last couple weeks here. What you're going to do is you're actually going to, before you graph things, and this is going to be true when you graph most things, is you're going to organize your data into a table. So what I'm going to do is over here is I'm going to make a table, and we're going to have a line for minutes, and we're going to have a line for gallons. And this is our table here. Got minutes on top, gallons on the bottom, and you're just going to go through and you're going to find some ratios that are equivalent to this. In fact, you can even use this ratio. So first off, we're going to put 8 minutes is 16 gallons. There's one. Find another equivalent ratio to this. Again, pick a number to multiply this by, pick a number to divide this by, and get another equivalent fraction. I'm going to take it down so my numbers are easier to work with. But let's divide each by, let's say, 4. And I can divide each by 4. This becomes 2, and this becomes 4. So I also have the ratio 2 to 4. You can inflate that more. I can find other equivalent ratios for it. You're going to find that you really only need 2, but we're going to find a couple more here. You know 2/4 is 1/2. You also know 2/4 is 3/6 and 8/12, and so on. I don't know what happened to it, Charlie. We're just trying again, hoping it doesn't happen to this one. So we'll say YouTube flagged it as it was inappropriate content. I'm not sure why it was inappropriate content, but it was, according to YouTube. So here we're graphing proportional relationships. Once you get a table, okay, this here is your table, you are going to pull out points from your table to graph. And your points are very easy to see. For example, we have our first point, we'll call it point A, is going to be 8, 16. And that's going with your first ratio. We'll have point B, which will be 2, 4. You can have point C, which is 1, 2. You can have point D, which is 3, 6. And you can have as many of these as you so think you desire. Bottom line is, though, when it comes to graphing proportional relationships, these are going to be linear, which means they're going to be a line. So when it comes to lines, you really only need 2 points because that's the definition of a line. In order to graph a line, so just for your reference, you will hear this a lot. Graph a line, you need to meet one of 2 criteria. 1, you need 2 points. Or 2, you need 1 point and its slope. Once you have this information, you can graph a line. Yeah, sure. What is it? Lyra, can you explain this? Yeah, I will. Charlie, are we taking notes? Yeah, let me get through the problem first, and then I'll answer some more questions. But this is the first problem in there, things that you should know. So first off, things you should know. 1, how to get this table. We're just making equivalent ratios based off of the original ratio given. Because it's an equivalent ratio to 8/16, it's 1/2. I took it off of 2/4 again. So 2/4. How do you get to 3 here? 2 times what is? Yeah, that was bad. I took it off of 1/2, I guess. Right, this I can divide by 2. I can divide this by 2. This gives me 1/2, and then 1/2 I took times 3 times 3, which gives me 3/6. But you really only need 2 points. This is how you're going to solve them. You don't really know what slope is yet, so it's not going to be a case of if I give you a slope, you can find it. But what you're dealing with is you're finding points. So what I'm going to do is I'm just going to clean up my work a bit. Point and slope. In order to graph a line, you either need to know 2 points or you need to know 1 point and its slope. I'm going to clean this up a bit. Let's see, I don't want this. And I don't want this. And we're going to move this over here just to give me more room. So what I'm going to do is then I'm just going to graph these points. So I'm going to draw a line. You'll note that everything is positive here, so I really only need quadrant 1. There should be a straight line tool somewhere. I don't know where there's a straight line tool. We're just going to draw a straight line. And so we have an x-axis. We have a y-axis. You're going to have a scale down here and a scale up here. These are your x values. X values correspond to the minutes. So over here we have minutes. Y values go with gallons. So here we have gallons. And we have a title for our graph, which is, what is it? Water used for showers. as our title. Yes, Eli, to graph a line, you need one of these two. You can either have 2 points, or you can have 1 point in the slope. Here, we're more focused on having 2 points. I have 4 points here. I really only need to graph 2 of them in order to solve this, but we're graphing all of them. So what we're going to do is we're going to come over here. We're going to make our X scale as best we can. Again, if you have graph paper, it's probably easier. But we're just going to count up by 1, 2, 3, 4, 5, 6, 7, and 8, I think is the highest we got. And then up here we got to go to 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 should be there. And please just try your best to keep things neat. Doing this on the computer is not the most ideal way for me to do this. But we have our graph, we have our title, we have our labels, we have our scales, and now we're going to plot our points. Let's start with point A. Point A is at 8 and 16, so 8 and 16 is all the way up in the corner here. And I'm going to call that point A. And then we have 2 and 4. 2 and 4 is about right there. That's point B. Point C is 1 and 2. It's about right there. And 3 and 6. Which is about right there. And then you're going to actually connect your dots. And again, try your best with a ruler. I just don't have one. And it is extended in both directions because it is a line, even though it does not make sense to have negative numbers here. We're just not going to read them. But this is our line. This is our graph. This is what it's going to look like. You'll note that it is linear. It is a straight line. Lines have arrows. And again, you only really needed 2 of these points in order to graph this. I just did 4 of them. So here, we are concerned about the 5-minute mark. If the shower time is reduced to 5 minutes. So, information we know. Again, in 8 minutes, we use 16 gallons. According to our graph, 8 minutes goes to 16 gallons. In 5 minutes, which is about here, you'll note that comes over to about our 10 mark. That actually looked pretty neat for what I did. Again, if you use a ruler, it's going to be a lot clearer. But this is our 10 mark. And that makes sense because if you were to do this proportion-wise, right, 8 minutes to 16 gallons, 5 minutes to X gallons, what is X? Here, X equals 10. Right? So in 8 minutes, we have 16 gallons. In 5 minutes, we have 10 gallons. And then it's asking how much water will be saved. So I want to know how much is saved between these 2 times. And in order to get that, you just subtract the 2. So I'm going to do 16 minus 10, which gives me that 4 gallons saved. And that's just interpreting the question and reading it from there. Just to recap, you got your original ratio. You made a table to get another point. Again, you only actually needed 2 because a line is defined by 2 points. Once you get your other ratio point, you graph it, plot the 2 points, draw the line, use the graph to read what you actually want, and then solve. And yes, you could do this without a graph. but today we're just looking at the relationship between them, because this gives you the answer to a lot more problems than just one by looking at it. Like, hey, what if I took a 6-minute shower? How much do I use? Just come up, oh, 6 looks like 12. And it does give you more information about it. That's pretty much what it's going to be. It is technically a half day today, so I didn't want to take up too much time with things. But what's going to happen is someone asked to go over some problems in the worksheet. So let's look at the worksheet problems a bit here. I think I really only asked you to go through one problem here. That too. So the worksheet, if you're following the worksheet, it's in your Google Classroom. It looks like this. It says methane is a chemical compound, and the ratio of carbon atoms to hydrogen atoms is always the same. And we're going to use this table to answer the following questions. So here, our ratio of carbon atoms to hydrogen atoms is any one of these ratios you want, because it's always the same. And you're going to look at the unit rate of it. Hey, unit rate is 1 carbon for 4 hydrogen. That comes right out of there. But you find equivalent fractions to get the unknowns. So you can complete that and kind of go through it. I can ask what I can give you a shot at that and make a graph. I'm not asking you to turn the graph in because I'm not exactly sure the best way of collecting that from you. But that's I was just going to ask you to make some things to read over it. Charlie is asking about the discussion question. And it's really not that difficult of a question. If I can even find it here. So the question is, what point on the graph indicates the unit rate, and explain. So let's look at this. And you have your graph. And unit rate deals with x over y. Is that what I want to do? No, it's actually y over x. Let's look at one with context. That might make it easier. What if we know speed? We can talk about speed today. Speed. Speed is defined as the amount of distance you travel divided by time. So distance divided by time. And then when we graph that, time would be down here and distance would be over here. To find the unit rate of this, you want it where your denominator is 1 unit. Right? So what is your distance at 1 unit? So when time is at 1, I want to know where on the distance thing you're going to be. And that's going to be dependent on how fast you're going. If you're going really fast, you have a high slope or a high steepness to your line like that, and one would be like there. Or if you're going really slow, it could look like that, and then your unit rate would be there. Or if you're not moving at all, you don't have a line, well, you do, it's just your speed is 0, which means your distance will be 0 and you'll be right on that x-axis. Yeah, fill in the question marks. It shouldn't be too difficult to complete that table. If I can look at it again. So then you're just explaining to me here, hey, how does unit rate relate to this graph? And you know your unit rate is always going to be when your x value is 1. So that's the question. To find your unit rate, you're going to look for when your x value is 1, what is your y value? So for the table, you have carbon versus hydrogen. If I have 1 carbon, I have 4 hydrogen. If I have 2 carbon, I then have 8 hydrogen. If I have 3 carbon, I then have 12 hydrogen. And you can see how it's going up. Well, it doesn't ask for 2, it asks for 3, it asks for this one. So you got to fill in that number. It doesn't tell you 5, but you can figure out 5, right? It's going to be 20. And you can use this ratio here to help you figure those out if you want to use proportions. Right, 1/4 equals 5 over 20. If I want 8, right, then I would say 1/4 equals 8 over what? And then you can use your proportions to figure that out. Is there a question you specifically want to go over, Kelsey? Charlie, unit rate is when your x value equals 1. So hey, x value is 1. So your unit rate is equal to 4 hydrogen. I guess I'll just use capital H for hydrogen, for carbon. I mean, you could flip them around and get that unit rate too if you wanted, but this one makes more sense. You could have 0.25 carbon per hydrogen. If you want the inverse of it, you just flip it. But this is probably the better answer there. And again, what does this mean? This means there's 4 hydrogen for every 1 carbon. If you were to draw methane, it looks like, hey, there's a carbon and there's hydrogen coming off of it. This is what methane looks like. You're going to explain what unit rate is. So you're looking for whatever your x value is at 1. What's your y value when your x is 1, Charlie? For Kelsey, number 3 here is just asking you to finish the table. Can we go over number 1/2? Is that 1 and 2, or are you making up one? What is the unit rate of hydrogen to carbon? So hydrogen is on top, carbon is on the bottom. I want the unit rate, so I want this where carbon equals 1, because that's what unit rate means. When your denominator is 1 unit, so 1 carbon, what is this? Looking at your table, it's already filled in for you. It is a 4 to 1, 4 hydrogens to 1 carbon, which equals 4 hydrogens per carbon. Number 2 is saying to describe what this means. This means in methane, there is 4 hydrogens for every 1 carbon. Number 3 is to fill in the chart. So you have carbon atoms and hydrogen atoms. It gives you 1 to 4. It gives you 3 to question mark. It gives you 5 to question mark. It gives you 6 to 24. And it gives you 8 to question mark. So you're going to find what this is. And you can look at that ratio right here. You can look at this to find that. 1/4 equals 3 over x. In that case, cross multiply. Well, I'll do it this way. Three times 4 is equal to 1x, or 12 equals x. So this one here is 12. Do the same thing with this one. You can have 1/4 equals 5 over x, and you get 20. Over here, you can do the same thing. 1/4 equals 8 over x. You get 32. Then it's going to say to graph the ordered pairs on the coordinate plane, label the x-axis carbon atoms and the y-axis hydrogen atoms. So what you're going to do is you're going to take, really all what you need is 2 points from here. So you only need 2 points out of here. We can do 1, 4. We can do, what was that? You said this was what, 12? So this was 20. You can do 3, 12. Graph those two. There's your graph. We have methane's ratio. This here is carbon. This here is hydrogen. This is number 4. Right? You just need to pick 2 points. Out of all the points in your table, pick 2 of them. Plot the points. So this point here was 3, 12, which came from right there. This point here was 1, 4, which came from right there. Connected the two, drew a line through it. There will be only one way to draw a line through this because you need 2 points to graph a line, and then so on. I'm not sure how you're going to turn in number 4 to me if you're typing things, so I'm just going to trust that you do that. So yeah, that's your answer question there. You're going to need to know this graph in order to do number 5. If you want to go through the trouble, you can, Lyra. I'm not going to take off points. I'm going to trust that you can do the graph by now. We just spent the whole chapter on it. But you probably want to do it just so you can answer the questions here, right? And then use your graph to identify how many hydrogen atoms are in a sample of methane that contains 7 carbon atoms. Now, methane is a polymer gas, so it does branch off, so it is possible to have 7 carbon atoms in this thing. So we're looking for when carbon equals 7, so 1, 2, 3, 4, 5, 6, 7. So when I'm here, again, you might have to extend your graph out some. Right at the 7 point, where does it cross this line? Well, this line has to keep going up. So it'll be somewhere over here. I don't know what you mean by do the thing with the line. Let's see here. Let's see if I can make my graph a little better for us. And we don't know. These are the points we're concerned with. That's a 4. So again, let's do 4 here. I don't know how to make a straight line on this thing. That might be a little better for us. Here we have carbon. Here we have hydrogen. I meant the graph in line. I don't know how to do that. You plot 2 points and you connect them. So let's say here is 1, here is 2, here is 3, here is 4, here is 5, here is 6, here is 7. That's all I need because I have to go out to 7. Up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm not going to have enough room on this either. 13, 14, 15, 16. Because again, we're looking, you can solve the proportion for this. I'm looking for 28. I don't know if I can get that back. And we'll just say 28's up there. And it says 7 should be up here, but let's look at 1 and 4. It's roughly there. My scale's not even here, so this isn't going to work out the greatest. And 3 and 12. And then you can see my scale worked out well. 7 would be around 28 up there. So number 5, your answer is going to be 28. But hopefully you can make a better graph than I can on the computer here. I'm not sure the best way to do it on this program. So I'm going to leave you there because technically this is a half day of school and I took more than half the class to do this. But if you could get this worksheet done, I do not need to see anything for 4, but you kind of need it for 5, and submit it to me by the end of the day tomorrow. That would be great. And I believe if you are missing anything from me, I sent you an email. Make sure you get any missing work to me by 3 o'clock today, or it's not going on the marking period. So with that, if there's any other questions, feel free to email me. But I've taken up enough of your time today. So. Okay, let's look at this. Number 5 is 28. Right? You can do that without the graph. Right? So number 5, 7 carbon means you have 28 hydrogen. At 7, this line crosses at 28. At least it should have. Okay. Yeah, you can use cross products instead of this. I mean, it's just another way to solve problems. Sometimes graphing things is nicer. Being able to read graphs is a good skill to have. So it depends on kind of what you're looking for and what you're in the mood to do. The discussion question. All right. This is our discussion question. What point on a graph indicates the unit rate? Okay, so unit rate, by definition, is when your denominator is 1 unit. It's a ratio where your denominator equals 1 unit. Okay, so by definition, this is the unit rate. So where on the graph is your ratio with a denominator of 1 unit? On a graph, the x-axis represents your denominator and the y-axis is your numerator. Okay, so unit rate is the y value when x equals 1. I'd like you to at least make a graph, Eli, if I didn't answer that already. Okay? And your explanation is because, hey, this is unit rate. So for example, again, I used speed. Speed equals distance over time. You have a distance over time graph. Distance, time. There's your speed. If this is 1, this value here equals your unit rate. And therefore you will know, hey, I am going For example, maybe I'm going 25 miles in 1 minute. So your speed is 25 miles per minute. There's your unit rate. Any other questions before I let you go? If you do, again, this assignment have done by the end of Tuesday. Discussion questions, again, done by the end of the week, if you can. You're not going to. Eli, you're not going to show me the graph. I'm going to trust that you did it because I don't know how to get the best way to get you to show me it. I mean, if you want to, you can take a picture of it and send it to me, but honestly, I'm probably not going to be able to make out the picture. Not everybody has a scanner to scan things to me, so I'm going to take your word for it. That's the best I got. And again, Eli, you can use cross products to solve things, yeah. However, I would like you to make the graph. It's just another way of doing it, and the graph gives you more information because it gives you every single equivalent ratio. It doesn't give you 3, it doesn't give you 2, it gives you all of them. So it's just a different way to show your answers. With that, I'm ending it. Send me emails if you have questions, or ask them tomorrow when we get in. We will look at similar figures a bit tomorrow. Okay.